Hello and welcome to another presentation in the LADAL Opening Webinar Series 2021. My name is Martin Schweinberger, and together with Michael Hoare, I'm co-directing LADAL, the Language Technology and Data Analysis Laboratory in the School of Language and Cultures at the University of Queensland, Australia. Before we start, I'd like to read out an acknowledgement of country, which we do here in Australia to express respect and gratitude towards the Indigenous people of Australia. So I'd like to say that we as members of the University of Queensland acknowledge the traditional owners and their custodianship of the lands from which we are broadcasting this webinar. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. I'd also like to say that we recognize the valuable contributions to Australian and global society. If you want to know more about LADAL and the resources we provide, please feel free to explore the LADAL website. The URL of the LADAL website is shown on the screen. No worries if you've missed any of our talks. Most of them are freely available on our LADAL YouTube channel. You can also find information about past and upcoming presentations in the LADAL Opening Webinar Series 2021 on the event subpage of the LADAL website. If you want to keep up with what's going on at LADAL, please feel free to follow us on Twitter or on Facebook. And if you have any questions, suggestions, or feedback, please do not hesitate to reach out to us by email. Now, without further ado, it's my real pleasure to introduce today's speaker, Joseph Flanagan. Joseph is a university lecturer in languages and English studies at the University of Helsinki, where he's also supervisor for the doctoral program in philosophy, arts, and society. Joe's research interests primarily center on issues related to English phonetics and phonology, reproducible research, and digital humanities. Teaching-wise, he's especially interested in exploring how digital technology can enhance student learning. Joe has presented, given talks, and co-organized several workshops on reproducibility and replicability in corpus linguistics at international conferences such as IL6 and ICANN 42. Now, I'd like to hand over to Joseph Flanagan with this talk, Reproducibility, Replicability, and Robustness.
Okay, thanks. So let me share my screen here. All right, so I guess that we're okay. Okay, so thanks. It's a great honor to be talking with other people that participate in this series with a lot of interesting talks. And I think that LADAL does a really good, makes a contribution to the issues that I'm going to be talking about here. So this is going to be a kind of high level discussion on reproducibility and replication particularly. And then I wanted to kind of just throw in robustness. And we'll be talking about, or I'll be talking briefly about what I mean by these particular terms, because sometimes that these terms are used interchangeably, sometimes they're not, and sometimes that they're used to refer to different phenomenon. So it's just going to clarify the terminology, although the terminology I think is not as important as understanding what the major issue is. Again, as Martin said, I'm at the University of Helsinki, and I'm in English studies, and then at the languages at the undergraduate. And just to kind of give some shameless self-promotion, that I wrote an article talking about reproducible research. And I went into a lot more detail here about what I think that involves in various different tools that involve R for how to do it. I'm not going to repeat myself here. I'm going to talk mostly about the larger issues rather than the details of it, but I just wanted to let you know that this exists. And again, I think that sometimes when people talk about stuff, that there's this idea that some people set themselves up as methodology police, or as one term was used, methodological terrorist. And I'll say here that in a lot of cases, it's not that I'm presenting this, that I know all the answers and that you should be doing this. But what I'm trying to do is articulate what I see as the issue is in the strongest possible way that I can, to commit myself to a position, and then that way people can point out where it's right and then where it's wrong. But again, that a lot of this stuff I'm still figuring out myself, and I want everyone to kind of be aware of that. So obviously the big elephant in the room is the whole replication or reproducibility crisis that exists across, let's say, the sciences in general, and not just simply, let's say, linguistics, but in psychology and the other sciences, etc. And I think the responses here is that on the one hand, you can just say that we're doomed, that when you see this idea that all these major results simply don't replicate, the idea is that there's something simply wrong with academia and that maybe we just need to start from scratch again. But an alternative is to just say, hey, look, everything's fine. Why worry? And carry on in the regular business as people might have. And I'm trying to kind of search for a middle way. So the thing I'd like to just kind of get back to first principles again, it's like, what are we trying to do when we do academic research and something that we're calling science? And I think that the kind of major questions that we have to kind of ask ourselves is, are our results reproducible? Are they replicable? Are they robust? And do they generalize? I think that all four of these questions really have to be answered in the affirmative if we want to do something that we're going to be calling science. And as I said, these terms sort of get used sometimes interchangeably and sometimes they flip about what they are. So I just want to specify how I'm going to be using these terms in the talk. And I think that when we look at the kind of things that we have involving, let's say, oh, that should be data and approaches, that on the one hand that we can say that if you're using the same data with the same approach, that's reproducible. And the idea here is that somebody should be able to get more or less the same numbers and the graphs and everything in your paper that you're reporting. The next step for that is, let's say that you do a different analysis. And when you're doing a different analysis on the same data, your results are robust. So that we don't want to say that the results that you get are contingent on very selective choices that you've made. But in certain cases that we want to be able to say that it should be robust to different assumptions that are in your model. And then if we look at the other column, we can say, now let's start looking at how we're going to differ in terms of the data. So that if we have the same approach but different data, then we can say that your result is replicable. And then I would say the most challenging aspect then is that we have different data with a different approach, and then we say that it's generalizable. And if you kind of wonder what I mean by that in a way, it's like in certain fields, let's say second language acquisition or even first language acquisition, metaphor studies, etc., tend to be making broad claims about human cognition. And in those particular senses, if we really do want to say that our results are somehow valid, it shouldn't even really be tied to a specific approach on particular data that we're using. But again, I think that this is the most challenging aspect of it. So in my way of thinking about what the hierarchy of this would be, I would say that reproducible is the baseline, but it's also the lowest. It should not be that challenging for somebody to get the same results with the same data that you got. That doesn't mean anything, though, because those results can be completely wrong. But the idea is before we can even begin discussing where they might be correct and where they might be wrong, we need to actually be able to get those same results and figure out what exactly that someone did. The next step I would say is that you're dealing with the same data, but you are doing that different approach. So then it's robust. And I think that once we start getting it robust, we can say, okay, well, this is good because now we're just not relying upon assumptions that you're making, but we have an idea that the data that you're doing or the analysis that you're doing is robust to different assumptions in the model that you applied. But you're still dealing with that particular data. And there could be something odd about your data that led to the results that you got. So that's where I think that the next step would be replicable. And I would say that that occupies, let's say, a more trustworthy result, that when you're able to get the same results involving different data, using more or less, let's say, the same approach, that's a higher level than either reproducible or robust. And then the highest level, and also I think the most difficult, would be something that's generalizable. And I'm only going to focus on these first two of the columns here about the reproducible and the replicable, because I think that there's enough issues that just surround these particular issues without getting into the robustness or the generalizability aspect of it. But again, I do think about these as being a particular hierarchy, and what we're ultimately striving for is the generalizable. Now, whether or not that anything involving human beings can really be generalizable is the open question that we're trying to figure out within our particular field here. So as I said, the first thing I want to talk about is a broad level of idea about what we mean by are the results reproducible. And when I say that something's reproducible, as I said before, I mean that you should be able to get the same results every time that you run the analysis, that there should be a way in which that if you're reporting particular numbers in your paper, or if you're producing particular graphs, somebody should be able to get those exact same results later. And if they can't get those results, there's a problem. But I think of reproducibility as basically being along a spectrum that you can say, because it's not an all or nothing aspect. So what you can say is that at the lowest end of the reproducibility spectrum is when you just have the text, and within that text that you have people reporting the numbers in tables. And I just wonder at some point whether or not this is really data then at that stage, because again, obviously to some extent that it's data. But at the same time, you basically have to take all those particular results on faith. You have no way of knowing when somebody reports something in a table, whether or not that those numbers are correct, because it's quite possible that nobody other than that particular researcher has even checked to see if they're the same. Then what you can say is that there's somewhere in between where people begin making some text available, they might make some data available, they might make some code available. And it could just be a mess that a lot of times people will put a lot of stuff up there, and that you're able to sort of to kind of look at everything and see what the person did, but it's not necessarily really clear about how they arrived at everything. But theoretically, it might be possible to do that. And then I think the 100% reproducible aspect of it is that a person can do it just basically by either pushing a button or entering certain command lines, or whatever it's going to be. But the idea would be is that they don't have to think that much about it. It's going to be something that anybody could basically do, provided that they have, let's say, the software skills, because I think anything involving reproducibility is going to involve a certain degree of technological skills. And I think at this stage that we're trying to figure out what exactly should be that level of technological skills that's necessary or should be necessary in order for somebody to reproduce the results of a particular paper. Now, I think that why reproducibility is so difficult some cases is that because I think a lot of times when we're actually doing an analysis, we're just kind of like trying to figure out stuff as we're going along. And it's not so much that we're just pushing buttons, but I think a lot of times that we have what we can describe as a rather messy process. And that particular process is one in which that we have stuff on our desktop. We're just writing code. If we're even doing code, if we're doing drop-down menus, we might be doing drop-down menus without figuring out. We're basically trying to get answers interactively. And I think that that interactive way of trying to get responses leads to a point where 6 months or even later after the analysis, we just don't really remember how it is that we got the results that we did. It takes a great deal of discipline to be able to remember what things you excluded or how you arrived at the results that you got. Especially drop-down menus, I think, are really difficult to remember what particular statistical tests you may have even have done. So the point is that when you're acting in that interactive fashion, I think that very often that the method that you use to get that has just disappeared. And the result of this is that within the literature, there might be a lot of mistakes, that there's various different things that what people are doing is that they're going back to be able to find out whether or not that there are errors within the previous literature. Let's say that, somebody basically wrote down a number in a draft and they had certain numbers that they had. And then later, for whatever reason, they decided to redo their analysis. But when they redid their analysis, they forgot to check all the different places where they had the original numbers. And so they have a mixture of different numbers from different stages of the analysis, that some of the numbers reflect the most recent analysis. Some of those numbers might actually reflect something that's prior to that. Now, this is psychology that I'm using as an example, and I'm going to give a lot of examples to psychology, but I'm not using psychology to say that this is somehow a problem with that particular field. I think that this is a field that actually is taking it seriously. And the fact that they're finding these errors is just simply, I think, a result that they're looking for them. And I think that if you're not looking for them, it's going to look like everything is okay. But I suspect that there's no reason why the psychological sciences would be any different from, let's say, the language sciences. there might be other things that we can say that psychology and, let's say, physics might have different issues that I'm not qualified really to be talking about that much. But I really just have my kind of own prior belief is that there's really nothing within psychology that would say that those results should be more suspect than the results that we do when we work with language, especially when you consider that there's a broad overlap between these two fields when we're getting involved with, let's say, psycholinguistics. And I think ultimately the kind of question is, why are we doing all of this? You know, that the thing is about the kind of process that we're doing, I think to some extent that we recognize, or like we're claiming that we're doing science and that we're trying to discover something about the world, but we have a process itself that I think that is increasingly becoming detached from what those larger objectives are. And I think that at some stage, if you just basically shrug and say, does it matter if I can't get the same results that I did 6 months ago? I think that it really raises the question about why it is that we're doing this research in the first place. If we kind of just say, hey, look, that's a paper that I wrote a year ago, I've moved on to something else. If people are constantly moving on to something else without really that much of a concern about the validity of what they've done previously, we're kind of building an elaborate house of cards that just might simply collapse at a certain stage because none of the results that we're reporting are really reliable. So I think in looking at this, and you know, if we start thinking about what we need to be reproducible, it really does become a rabbit hole that's easy to fall behind, because we have to be able to have something about data creation. If we don't know how we gathered the data that we're analyzing, if that's not reproducible itself, nothing else is going to be, because there's that stage where the data itself just doesn't exist preformed. We did things to create that particular data, and we need to be able to explain to people how we created the data. Then we have a thing where any kind of modeling and analysis that we did also has to be reproducible. Even if you just simply say, I did this particular package in R, does not really explain to a particular person how they themselves can get those same responses. So we have to kind of take care of the modeling and analysis. And I think that we also should be able to think about the connection between the reports that we have and then the modeling and the analysis that we got. Because there's an awful lot of errors, I think, that come in just because what we're doing is we're copying and pasting from one aspect to another aspect. And when we do that copy and pasting, it's just really, really easy for mistakes to come into that process, so that our modeling and analysis that we did becomes out of sync with the reports or the papers or the documents that we produce that kind of report on what that modeling and analysis result. And if you involve any kind of software environment involved in that process, this is the hardest aspect of it, that if the software environment itself is not maintained, then we're not going to be able to get those results either, because the idea would be that packages may have been updated, functions may have changed, software may have become obsolete. And if any of those things occur, then we're not going to be able to reproduce either how we gathered the data or how we did the analysis and how we got those reports on it. So this is a challenge. I mean, when you start thinking about what's actually involved in this at a high, like, you know, in a detailed level, do we actually know that 10 years from now, the particular method that I've had to, let's say, maintain the software environment is still going to be viable? So really the kind of aspect when somebody starts thinking about this is to say, look, this is going to be an impossible task, right? How can I possibly do any of this? I don't have time to be able to worry about all these different aspects of it. And I do think that there's something to be said about this, but at the same time, again, I want to come back to, if we're doing science, these are things that we should be concerned about. Landmark results, I think, should be something that we're able to reproduce 10 years from now, 20 years from now, because if we don't, or if we're not able to reproduce those results, but we're only reproducing what somebody said about those results, we're kind of, again, acting on faith. We're not really doing science at some point, that we're just passing on, let's say, tradition. So some of the things I think can help here is that one is, I think, just having a project template could be somewhere to get started. And what I mean by this is, like, again, start small. You know, that reproducibility doesn't have to be an all or nothing process, but I think just having something like a consistent directory structure is going to help. So generally what I do for almost any project that I create is that I always begin with the same basic format, where I have a data directory that contains the raw data that basically stays untouched. And then it's a lot of different stages of that data where I can either process it or it's some intermediary form of the data. And then external data would be where I would get from somewhere else. And the idea would be that the interim data, the directory and the process data directory should just be able to be deleted because I'm going to be able to reconstruct that from the source directory. But anyway, you have a license to tell people what they can do with it, because again, that if you make it reproducible, but you don't allow people about the legal aspects of it, they might not be sure what it's going to have. A lib directory, have any external functions I might have. The documents is where all the reports are. And then, as I said, with the source file, I tend to try to have it so that I have one directory is just concerned with this is how I created the data. The features and models and visualization are ones that are more specific to the analysis, that I try to make it easy to see how it's going to be. Now, the alternative method to this is to throw everything into, let's say, a Jupyter notebook or in terms of a R Markdown document, rather than having separate source directories for R scripts. And we can talk about this in the Q&A, but my own preference is that if you put everything in an R Markdown document, it gets really hard to reuse it later. And that very often that the same analysis might have a paper attached to it, and it might have a presentation that's attached to it, or other venues with that. And if all the code just exists in an R Markdown document, I have to manually copy and paste it from one thing to the next. And I think that the problem with that then becomes that it gets really easy for those different versions to become out of sync with one another. So I prefer importing my functions rather than actually including them in a particular document. But the problem with that is that it might become a little bit divorced from the particular paper itself. And for that reason, that the connection between the two might get broken. So as I said, it is a challenge that there's not really a single answer about what the best approach is. But I do think that just starting by having a single directory, that if somebody says, how can I, hey, can I reproduce your results? Can I get the same? Can I see what you did? You just zip up this particular directory and send it to them if you don't have it publicly available on GitHub or OSF as an example there. Now, as I said, I think the biggest challenge of this is like if you start thinking about what needs to get reproduced at this level, I think that at the highest level, when we're talking about the project scripts, those are the easiest ones to be talking about how we can make it reproducible. These are ones that you yourself control. And I think that because you yourself are using them, it's the easiest to make available, and it's the easiest to make sure that everything's up to date. But we also have things such as specialized packages. We have general packages. We have scientific software. You don't necessarily have control over these, because if you're relying upon packages that other people have produced, or even if you're relying upon, let's say, R or Python, you're somewhat relying upon changes that other people may have made to it. Python made a major transition from Python 2 to Python 3 that basically broke every single existing Python 2 code. So, basically anything that was written in Python 2 is basically going to become obsolete because you're not able to run Python 2 with Python 3. Even R, which tends to be pretty stable, had some breaking changes with R 4.1, which was a necessary change to make. But those kind of necessary changes that they made also means that you're going to have problems with older versions of R prior to that relied upon a different version of R, and that the would have to be manually updated, let's say, for it to be able to work, unless that you did something else. But the more complicated tools that you get, we're getting into system tools and libraries and operating systems. And I've worked across platforms on Windows, Mac, and Linux, and it's really, really hard to make sure that something runs on all of them consistently. It's relatively easy to do it at one slice in time, so that if you're talking about, let's say, June of 2021, let's say, it's not that hard to make sure that it's going to work across all these different particular platforms. But as soon as that you're getting into certain number of years later, it gets really, really hard to know what kind of changes get made in the operating system level in order to maintain that. So again, I think about this. This is not something that's easy. This is something that's actually pretty difficult. I think that at the top is the easiest, And as you get further and further down the pyramid, we become more relying upon these things. And what's kind of more or less the problem with that is that the more relying upon it that we are, we also have the less control over it. And there's also a kind of attitude in a lot of software development right now that just basically says, let's break things and make it better. And that's sort of contradictory to, let's say, a scientific idea where we want to be able to maintain consistency in order to have the same analysis. So right now, the software industry and the needs of academia are basically moving in two different directions, which creates a certain degree of tension in this idea of being able to maintain reproducibility. But it's just something that we're working with. There are tools, but again, none of the tools are really 100% foolproof. So as I said, I think to really kind of get involved in this, and that this is where it's difficult, is that really we're going to have to get up on software engineering techniques, whether or not that it's going to be in an individual level or whether or not that it's going to be at the community level. There are solutions within software programs to deal with all these particular issues, but it is a very, very specialized knowledge, especially as we get into the more nitty-gritty details of various different things. And I think a reaction that people have is that this is just unrealistic for somebody whose primary job is to do linguistics to become a software engineer. And I recognize that, and I don't know what the solution is. To some extent, I do think that it should be a community response where we decide that there are certain results that are so important that we will make sure that these things are completely reproducible in the sense that we take a lot of effort to maintain them. And then other ones, I would say that we look at more higher ends of the pyramid where individuals are concerned that their own analyses are at least reproducible for a couple of years, but we're not committing ourselves to a long-term endeavor because, again, I do think that that might be beyond the level of an individual researcher to be able to do, especially when there's no money that's available for it. That's the kind of problem with grants very often, that they fund the research, but they don't fund the maintenance. And again, it would be interesting or, let's say, important for people to become more aware of saying that the research is just not the paper that's permanent. The research that you do is something that everything that goes into that paper. And in fact, the paper itself could arguably be said to be one of the less important aspects of it. But of course, what I do want to say is that the interpretation that we give to the research that we've done is also a crucial aspect for linguistics. So I don't want to say that it's trivial, but I do want to say that I think that maybe broadening the notion about what research is going to be a necessary task for the future. And there are, as I said, there are plenty of tools that can help us with all these things. I'm not going to walk through them all, but I think that, you know, there are different responses that the R community has developed things. R Markdown is a great tool. I think Python has some really good tools for maintaining software environments. We have Git that can maintain stuff. We have various different databases. We have Docker, which, again, you know, is it going to be around in 20 years is an open question, but at least at the stage that this does allow us to more or less freeze a particular software environment and to be able to do that in the future. We have the Center for Open Science, which basically exists as a means for academics to be able to store and share their work in the future. So there are a lot of different tools that are available because this is a software engineering problem to some extent. And the larger than issue becomes, how do we actually learn how to do these things? And I think that LADAL is doing a really marvelous work in explaining to people how it is that they themselves can take advantage of these tools without themselves going to, let's say, university to study computer science. Okay, so the next stage of the talk I want to kind of move on to is the how do we make our work replicable in that sense. And replicability, as I said before, is this notion that you take the same approach, but you do different data and you get the same results. Now, I'm not going to actually get into what the same results are. And I think that that's a really, really hard question because on the one hand, I think that we always have this kind of idea that same results are, I think that what we intuitively do as we read the literature is we look for significant results that are out there. And if something reports something lower than, a particular cutoff value, then we say that it's good to go. And then we would say that it might be replicable. But again, I think that there should be enough alarm about p-values and the reliance upon v-values in the last 10 years that we realize that that doesn't necessarily mean all that much in the long run, especially when we're involving things that don't involve, let's say, fertilizer. You know, that a lot of traditional frequentist statistics was created for phenomenon that just isn't studied by us. And it may not be that appropriate for determining whether or not fertilizer has an effect is going to be the same thing about the kind of phenomenon involving human beings that we ourselves are concerned with. But in any case, I'm going to put that aside for right now because it's a huge issue, and I'll address some other kind of issues that I see here. Again, obviously, the starting point of this was an analysis done in the 2015 where they kind of went out to psychology and they found that a lot of different things did not reproduce, and it was really alarming. Or I should say they weren't replicated here. They used the term reproduce when they were talking about what I'm going to refer to as replication. I've updated it here, but the idea of replication is people just got different results, and that this again was in psychology, and some landmark studies that they found that people had made its way into textbooks when people looked at it with bigger data, etc., just were found not to be able to get the same results when applied to a different particular population. And what that means now is something that we're exploring. Now, the reasons for this, again, probably the most obvious example is the file drawer effect. And what you think about what the file drawer effect is that if you get a negative result, we don't publish negative results. We tend to publish positive results. And as a result of that, any negative effect goes into a file drawer and then never gets published. And if it doesn't get published, that means people aren't aware of it. And as a result of this, and this is really old, when I was doing research for this, I was surprised by how old of a problem this is, that this was reported by Sterling in 1959, where he said that, like, look, if you have any field that depends upon statistical tests of significance, you know, what's going to happen, non-significant results don't get published. If they don't get published, then they are, you know, they're unknown. So people just keep on doing the same thing again. And then eventually, you know, again, a p-value of 0.05 basically means a 20% chance that you're going to have a particular error, as they describe it. And so that's going to be out there in a way, right? So if enough people are doing research on a phenomenon, you're going to get more or less errors in the field where it comes up with that. And then if only those results are the ones that are published, you can have an entire field that just basically has false conclusions. And I said, it's interesting here that this was in 1959 that people were talking about it. And we're still talking about this exact same problem in 2021, which is a bit alarming, I think, in that sense. But again, that we'll kind of move on here. Now, again, some of these kind of problems that we could have is that a lot of analyses that we do involve very noisy measurements, you know, even if we're doing, let's say, basic sociolinguistics, and if you're relying upon these large categories such as gender or class, it's obvious that that's going to be a very noisy measurement of the social group that we're trying to look at. A lot of different studies might have a lack of statistical power in the sense that, you know, that again, that if you're dealing with something and let's say that you're doing a sociolinguistic study and that you have 5 participants per cell, there's a question about how much statistical power you're actually going to have in that particular analysis. How large do our sample sizes have to be in order for the results to be reliable? And I think that what happens here then, and that this is combined with the idea that you only publish statistically significant effects, rather than thinking just about like, okay, hey, what kind of type 1 or type 2 error is it? What we can have is that Andrew Gelman had this idea of what's called a type N error, which means magnitude error, or type S error, which is a sign error. And Vasishith et al. Kind of published a paper involving with psycholinguistics that basically said, hey, look at this. Let's do this particular kind of study. This is a simulation here. So it's more of a simulation. but we have an effect at 15 milliseconds, right? We have a standard deviation of 100. If we look at this, most of these results are basically that they would say that they're significantly insignificant. Those are the kind of triangles that you go here. But the important aspect to focus on is the ones that aren't, because there are going to be things that are statistically significant. And if you're not aware of all the ones that weren't, and you only get reported on the ones that are, we'll see that here we have the wrong sign, right? All these have really big magnitude. If this is the particular magnitude of the effect here, anything that's going to clear it is going to be much, much higher than that. It's going to be an exaggeration, right? So the idea of what's going to happen is that what we're going to have is that we're going to have very exaggerated effects. If you then decide that you're going to calculate power for a future study, and you're relying upon the effects that have been published in the literature, you're going to have extremely exaggerated ideas about what the expected effect sizes are going to be here. So again, there's only going to be a handful of studies that actually wind up to be significantly significant. We have 1, 2, 3, 4, 5, 6 out of all of these. But the idea here is that we don't understand, or we've never actually seen the ones that aren't. We only see the ones that are, and all of these are going to be exaggerated in terms about what effect sizes that they're reporting, and people rely upon this for other downstream applications, which is going to lead to a particular problem. There's also a question about what kind of winds up being questionable research methods, where people really kind of say, look, I'm just so close to being able to publish this paper. What if I just kind of make some changes here and there, and then I get the particular, I cross the threshold, so it goes from being unpublishable to being publishable. And I think that these questionable research methods, I'm going to use this term in a broad sense of the word to say it's not necessarily fraud, although that does exist. In many cases, people just might not be aware of different issues that or consequences of decisions that they make, and they think that they're actually doing something good when in fact they're dealing with something questionable. And I think that a prime example of this was, that should be Brian, not Brain, but Wozniak, who was a researcher at Cornell doing a lot of things with food studies. And he wrote a blog post, and he basically described, this was like the grad student who never said no. And he wanted to use this particular grad student as a model for how things should go. And how he described it is he gave her a data set that was a self-funded failed study which had no results. And he said to her, look, this cost a lot of time and our own money to collect. There's got to be something here that we can salvage because it's a really cool data set. And then he had certain ideas. He said, look, why don't you do A? You can do this, you can do this, right? It's only plan A that didn't fail. So why don't you just dice it and slice it until we get a result that's significant? So he said what it should be, what the table should look like. She did them 6 months after arriving. She had 1 paper accepted, 2 papers with revision request, and 2 others that were submitted and were eventually accepted. So the whole kind of point is that he wrote this as a blog post, not as a self-critique. He actually did this as a way of saying, look, fellow grad students, this is what you should do. If you do a study and you get a negative result, don't despair, because there might be ways where you can go back and dice up your data set in a particular, or your analysis in a particular way, so that you ultimately get a bunch of papers out of it. So we went from a study that basically had no results when it was conducted one way to a study which basically generated a number of different papers that made its way into the literature. Now, again, that when it became known, there was a huge outcry. People did kind of point out to him that you obviously don't know what p-hacking means if you're going to actually use this as a particular model. But I think that a lot of people intuitively think that there's nothing wrong with this. You do kind of exploratory analysis first, and after having done exploratory analysis, you do confirmatory analysis, already knowing what the results are. It sounds perfectly reasonable to do, but it's going to really increase the number of error rates about what it is that you're working with that way. Another kind of one, and I think that this really kind of launched what I would say is the kind of crisis within psychology, is when Darrell Byrne, for various different methods, was able to show that Cornell students had precognition. And I think, again, what's a bit interesting about the kind of academic machinery here is that the media relations of Cornell didn't publish this as a kind of way of saying, hey, look, you know, students don't have precognition. This violates the rules of physics. But they kind of basically said, hey, let's just basically get into this whole point of being able to say that, you know, that let's promote the study, right? Let's just basically say that, hey, look what our researcher did. He actually showed that the laws of physics don't necessarily apply, rather than you think the standard reaction would be something seriously went wrong here for him to be able to produce a study that suggested this. And again, I think this leads into what on earth are we doing? Like, I mean, universities are under tremendous pressure to publicize the results of their researchers, and the subtleties of what they results show versus the claims they make about it very often get lost within that aspect to it. So again, I think that we have a question like, is this science then at a point where instead of basically getting a result and wondering whether it's true, that we just promote the hell out of it, and because it's, or people think that it looks good in that way. Now I'm going to just wrap up with some general issues I think that we should be kind of concerned with, just to kind of look at it, that I think that in a large sense, and this is kind of like what I've been thinking about recently, is that rather than thinking about a reproducibility crisis or a replication crisis, I actually begin thinking that we have a theory crisis. Because what's happening very often, I think, and this goes back to the precognition study, that so much violates what we know about the world, that to do a large scale study that would be probably really expensive to disconfirm the idea that Cornell students have precognition is a complete waste of resources. And I think that ultimately, very often that what we have here is that we have this idea that we have a lot of data, and very often that the theories that we have are very, very weakly correlated with the data that we have and the kind of results that we have. So this is an example of just, you know, up until like the Renaissance area, about when you're predicting the movements of the known planets around the Earth, this made really accurate predictions, you know, that they were able to predict where various different planets such as Venus and Mars were able to appear in the night sky. The problem is this model is just completely and utterly wrong. So the idea here is that we can have data, and we're actually able to make somewhat decent predictions based upon that data, but the explanatory mechanism behind that is completely off. And this is where my kind of hope is, in a way, about where, let's say, linguistics and corpus linguistics can maybe kind of counteract a lot of the hype surrounding deep learning methods, because I think a lot of deep learning natural language processing right now is precisely this idea of prediction. You know, we don't know how it works. What's important is that we're able to predict what's going to happen. We're able to predict and accurately predict what we can expect. And I would say that what our contribution here is, we're never going to be able to compete with them with the amount of data. They're going to have more, Google's going to have more data than we will. But I think that what we should begin thinking about more are these kind of causal mechanisms that is not being explored there, because ultimately what we want to be able to do is that we want to be able to intervene in some level. And I think intervention is just the complete opposite of prediction, because you can predict something pretty accurately, but that doesn't mean that if you intervene, it's going to have the effect that you think it's going to have. The only way that intervention is going to have a meaningful effect is if you understand the causal mechanism behind what generated the data. So as I said, ultimately, I think that the replication crisis is basically a theory crisis, that ultimately where the problem is that we have a lot of theories that are only very weakly related to the particular types of statistical analyses that we're doing on our data. And what we need to do is that we need to have better linguistic theories that match up with the statistical analyses that we're doing, so that we're just not mining noise, but that we have some kind of a connection between the two. These might involve modeling things. So again, that this is an example involving the Stroop effect in psychology, and it just has to deal with the rather, what seemed might be a technical kind of aspect of it, that when you do a regression model, do you have subjects like in terms of fixed effects, or are they random effects? And what you can see here is when you have them as fixed effects, which is what a kind of standard, let's say, regression model would do, it looks like you have a very tight estimates here around a particular estimate. However, again, subjects are going to vary. That when we do these particular experiments, we do not expect the subjects to stay the same. That's the whole point of kind of this, that we're looking to see something that generalizes beyond the people in a particular sample to larger particular samples or different kind of subjects. So basically, subjects should be modeled as being random effects. But when we look at these particular random effects, we can see that the estimates here blow up just in terms of our expectations about what it's going to be. So here, if you just see a table like this, it looks like that you have a pretty confident estimate that you can depend upon. But if you just change the modeling decisions that you have, now all of a sudden, this looks like a very, very suspect, or at least we don't know what the estimate is. We're not exactly sure. That these are very wide intervals that might make us want to think more about how confident we are to produce the effect that we're describing. Another kind of aspect to it, and that this is again an idea related to regression model, is let's say this is a basic kind of, again, a demonstration. It's not actually empirical, but the good thing about simulations is that simulations really do tell you something about your model to some extent. But let's say you take 200 research proposals and that you rank them on a scale of trustworthiness and newsworthiness. And then you select the top 10% to be funded, right? Which is kind of like what you would expect. There's no correlation between, let's say, trustworthiness and newsworthiness before selection. But then once you've selected them, it becomes negatively correlated. And the correlation is pretty high. It's negative 0.77. And again, the point here is that this is not a causal mechanism. It's not saying that newsworthiness causes a lack of trustworthiness. That's a kind of question about how we have to think about our modeling. What exactly is going on here? What is the kind of collider, as we would say, and how do various different colliders affect our analysis when we're doing these particular things? Is not an easy question to answer. The other thing I've been thinking about too, it's when we're thinking about what it is that we're doing when we're doing our analysis, there's multiple levels that really to kind of do our analysis, we have a lot of different models that we're kind of looking at in our head. On the one hand, we have a process model, which basically says, what do we think generated the data? There has to be some kind of a mechanism that we think generated our data. And what we're trying to do is to come up with a model that explains how the data came up. However, we also have some things. We know that just with random sampling, we're going to get some effect, right? That random sampling means that there's going to be some differences from one sample to an X. So we should actually throw that into our particular idea about what we think is going on. I got this from ecology, but I think linguistics has a lot to do with ecology, especially if we're talking about corpus linguistics or sociolinguistics, because now all of a sudden we also have to say, it's well, look, what is the what kind of issues are going on with our ability to observe this in the first place? That if we are just going to do a random sampling, okay, there will be differences that are just involved in random sampling. But how likely are we to observe this particular phenomenon? What could affect the ability for somebody to have the thing that we're looking at in that sense? And that's what an observation model would be. And then I think parameter models, because this is basically Bayesian, is basically saying, look, we should have some prior knowledge about things. What makes us experts is that we have certain expectations about how we believe the world exists. And if we get something that just completely goes against how we think the world exists, there's probably something wrong in our analysis. So putting parameters on our expectations or our prior knowledge isn't really a way of tilting the scales to get the result that we want, although I guess that it could become that. But it's just basically trying to inform expert knowledge in the process, because ideally speaking, we want to think that the expertise that we've developed should be able to affect how it is that we're thinking about the models that we have. And as I said, recently, what a lot of people are then talking about is like the very, very crucial need that what we have right now is how to take vague verbal theories that we have and we often express, and how to turn that into a formal model that we can actually empirically test to be able to say that, okay, this verbal theory is, you know, again, it could be compatible with a lot of different effects that we might see. So the idea here is that we want to try to say that how can we actually design studies that test for the things that we're interested in? This is involving a different issue than linguistics, but I think it's the same issue, that the larger kind of issue is that we have vague theories. We need to turn these into formal models if we want to understand empirically what's going on. And I think if you kind of look at where the profession is right now, you know, that this is a model of diffusion of innovations. And I think that we're beyond the innovator stage, but I think that we're still probably in the early adapter stage of all these particular issues. And the question is, how do we jump from this early adapter stage to the early majority stage? That this is a kind of chasm in a way that as a discipline that we need to figure out how to get through. Because I think that what we're working on right now is how to get, well, the innovators did their job. These tools are available. The ideas are out there. The early adopter phase, now we're making it a bit easier how to use this, and we're making people aware of these different tools and issues that are involved with that. But there's still quite a bit of jump between where we go from the early adapter stage to the early majority stage. And again, I think that this is something as a profession we need to be thinking about. How is it that we normalize these things so it isn't just a relatively small number of people that are doing this, but it actually affects the community at large? I don't have any answers for that, and I'm not in a position to actually have any effect on this. But I think that this is an issue that to some extent helps to be thinking about. And I think when you really think about this, you really have an idea that current practices are so entrenched for various different good and bad reasons that it's actually hard to see how you're going to dislodge them from the kind of predicament that we're stuck in. So that's an open question. I don't really have any solutions, but I think I can identify some of the issues. And I want to end here by just talking about what are some of the issues I think that cause the problems, and maybe not so much state what the solutions are, but just at least to make them visible. I do think that there's still a certain degree of technological challenges that, again, I think early adapters are people that are interested in technology and that will learn this stuff. But I think to some extent, we haven't mainstreamed this enough yet. So there's still a great deal of technological challenges that we have, especially for people who come to us in the humanities that aren't necessarily interested in software engineering, let's say. There's a huge issue about making data available that, you know, the question that always comes up when you talk about reproducibility, that somebody says, well, I can't share my data, what should I do? And the question is like, on the one hand, well, if you can't share your data, you can't share your data, end of discussion. But it is an interesting thing that there's a tension between, let's say, privacy concerns and reproducible research. And I don't think that we have a good answer to that all the time yet, because my default thing is like, on the one hand, if we say only publicly available data can be used, a lot of communities might remain unstudied. And a lot of those communities will be vulnerable communities that we actually need research done on. So those privacy concerns and not sharing data would have really negative effects if we said that we can only work with open data. At the same time, we have the problem, how can we rely upon it if nobody else other than that one researcher actually sees the data? So the legal issues, I think, are huge. And I think that they're only things that we're beginning to understand given the complexity of the issue that surrounds it. I think a lot of people are just afraid of making their stuff available because, you know, again, that rather than thinking about this in terms of science and we say, okay, we expect most things to be wrong. I mean, my default prior is that if something is novel, it's probably wrong. And if it's not completely wrong, it's just like the magnitude is off. There's a lot of things that can go wrong with cutting edge research. That's almost what the definition of cutting edge research would be. We should expect there to be failures. I think that the problem is that we kind of got into a framework that rather than saying that error is inevitable within science, we have this idea that if you say that something doesn't replicate, you're accusing them of cheating or it should be retracted. And retraction has this really kind of, it has this serious sounding word to it that makes it seem as if that there's some major consequences to a particular person's career if their work has been retracted. And the fact is that for a lot of early career researchers, that's probably true. It would have that. But I think we have to normalize it. We have to say retraction isn't bad. Retraction is what happens when you look at stuff. And that rather than just trying to pretend it doesn't exist, i.e. the errors that are within that, we should be much more reclined to make it easy to see which studies should be retracted, because literally speaking, the conclusions that they have are not reliable. But it shouldn't negatively affect the researcher either. And that's the kind of tricky aspect to balance there. Again, we're not software engineers, and I think a lot of people are embarrassed by the kind of work that they do, and that they are afraid that if they share their code, people are basically going to say, my God, I can't believe that you did that. And I think anybody who's actually coded themselves, if they look back on things that they wrote 5 years ago, would also cringe about what it is that they thought here. But again, I think that this is a legitimate fear, and I don't know what the answer to it is, other than we should be nicer as a community. But I think that this is a real psychological barrier that we have to address. I think that there's this fear of being scooped, I think, in the sense that people think if I make my analysis available, then somebody else will be able to steal my ideas and they'll benefit from it, and I don't. I think that this tends to be more apocryphal than real, but it probably really does occur. I mean, that the possibility is there. Now, this is a little bit different than somebody else gets credit for what you did, because I think even as a field, we have an unfortunate tendency that citations sometimes reflect the name of the person rather than the contribution that they made, and that some people get associated with ideas, even though they themselves may not have innovated it, because they have a bigger name at the time. But again, I think that that's a social issue, and I think that we don't solve social issues by pretending that they don't exist. We try to address it by figuring out what is the particular issue. And one of these things is that preprints should count. You know, a lot of stuff I think should count more than what it does. And again, that if you make it publicly available, you can say this is a way of not getting scooped, because in a way you've already set out a public declaration that this is your original contribution. Another kind of aspect of it, and I think that this is just if you involve stuff long enough, if you make code available to people, you're probably going to get people who don't know that much asking you for help all the time, saying that like, look, I want to reproduce your thing, but I can't do this, and I can't do that, and I can't do that. And people are going to get a bit concerned that they might be answering an unending list of email messages when the people might not get those results for a lot of different reasons. And some of it might be that they're just not necessarily qualified to do the replication study. And I think that people can vary in terms of their generosity, but if you put something out there, the number of requests that you get can be infinite. And if all of your work is now, future work is spent answering questions about work that you've done in the past, people will feel that they're not making any progress in terms of their own stuff. And I think that just one of the reasons why people do this is they don't want to be bothered with it. And I do think that the profession over time has developed bad incentives. I think that in a way that what we're beginning to emphasize for a lot of different reasons that probably started out well is that we emphasize certain notions of productivity over good quality research. And ultimately speaking, bad research will drown out good research because bad research is easier to do, it's faster to do, it's easier to get particular results. Good research takes a longer time to do, and that very often the results that you get aren't quote unquote newsworthy. And as a result of that, we're kind of misaligned with the idea about what it is that we want to accomplish by saying that something is a reputable scientific field. But I do think at some level, and this is how I just come back to this all in my head, that, you know, I'm using unproducible research here in general, but I can kind of say with all the particular issues here. I think that if we do want to claim that we're doing scientific work, we do have to do better than what we're doing, and we can do better. We know what it is that we have to do. In the last 10 years, I think that we've learned a lot. You know, the whole kind of so-called crisis within science I think is actually a good thing in the sense that this is how we learn things. And I think the question now is what we learned from the past decade and how we can, let's say, create a new paradigm for doing science. Because again, that with Kuhn, I think that what people kind of forget in Kuhn is that he also used the notion of crisis, but he said that crisis is the point where you're moving from one paradigm to the next. One paradigm is basically seen to be inadequate. A new paradigm has to be born. And I think what we're moving here is this idea that we can begin seeing the outlines of a new paradigm for how we can do better scientific research than we've done in the past. So this is the way of looking at it. I want to thank everybody for this. I think that this ends the talk here. So I'll stop sharing and questions.